Okay, welcome back to the videos. We're in section 2.4 right now, and um, this involves the kind of work that a lot of students don't like, and that is taking verbal expressions or verbal sentences and then making them into expressions or algebraic expressions or algebraic equations. Well, hopefully we'll provide some good tips for how to do this here. And I'm going to work through a bunch of the problems, which again are going to be very similar to what you're going to find in your homework. So if you're feeling stuck in your homework, these should be helpful. So let's go ahead and take a look at this. It says write the following as an equation, then solve. The sum of 9 times a number and 6 is equal to 8 times the number. So oftentimes when you see the word is, that will usually be sufficient enough to indicate that that's going to be an equivalent to basically being equal. But they do say is equal to. So what I'm going to do here is I'm going to establish where the equation is, because what I'm going to do is I'm going to split this verbal sentence into two different parts now. And the first part I'm actually going to go after is going to be the part to the right, because that one's a little more straightforward than the other one. Now typically, if we have something referred to as the number, that is something we're going to use x for. So what I'm going to do is I have is equal to 8 times the number. That's going to give me 8x. But let's take a look at what's on the other side, because the other side is a little more complicated. Because here we have the sum of 9 times a number and 6. Now, when they talk about the sum of, that means that we're looking at this. We're looking at this portion of the sentence here. There are two things we're going to be adding up, this and that. So where you see the word and when they talk about the sum of in the beginning of the sentence, the and part is going to be the plus sign. We already know is equal to is that, so this first part is going to be 6. So what's this first part? 9 times a number. 9 times a number is going to be 9 times a number. So if you take a look at how we've put that all together, we now have 9 times x plus 6 equals 8 times x. So let's go ahead and write that a little more simply here. 9x plus 6 equals 8x. So you're asked to solve these equations here, but this video is actually not going to cover solving the equations, nor am I going to solve them for you. Not in this video. The focus of this video is not to solve the equations. The focus of the video is to write the equations from verbal phrases or sentences. Let's go ahead and take a look at problem number 2. 3 times the number minus 8 is equal to 2 times the number plus 7. So first, let's divide the sentence into the two parts. Here's the equal sign. And let's take a look at the first part because it looks shorter. 3 times the number minus 8. Okay, so we have a minus sign. What are we subtracting? 8. It's 3 times the number before that, so that's going to be 3 times, what's the number? X. And what's that going to be equal to? 2 times the number plus 7. Okay, so that's, we don't need to worry about translating that. Just whatever 2 times the number is. So that's going to be 2 times the number. Number plus 7. So when you see a verbal phrase written out like that, try the best you can to write above that and make sense of what's going on with it. So in short form, this is going to be 3x minus 8 equals 2x plus 7. So 3x minus 8 equals 2x plus 7. And now we've taken the verbal expression and we've now written into an algebraic equation. Let's take a look at number 3 now. And by the way, if you would like to take a look at these and try these on your own before seeing how you work out the solution, you are certainly free to do that. So you may even want to try to write some of these out and then try to put it together. Now, again, the first thing I try to, when I'm reading this, I want to make sure, is it an expression or is it an equation? Once I see is equal to or is, chances are it's going to be an equation. So I want to establish that first so I can take a look at the chunks of the problems. So to the left of here is one chunk. It says twice the difference of a number and 8. Okay. Now, not everyone knows what twice means, but twice is a way of combining two things, the number 2 and the multiplication operation. And since we're talking about the difference of something here, we're going to talk about it's twice this difference, whatever this difference is. So this difference is going to go in parentheses, and there's going to be a subtraction symbol. So what is it the difference of? A number, and I should probably put this here actually, and 8. So what's the number? It's going to be x. So twice, 2 times the difference, there the and, of a number and 8 is equal to 3 times, and here we go. So this is going to be 3 times the sum. Okay, so we have some multiplying this, so we're going to have here for the sum of, well, let me stop here actually. The number, so it's the sum, so I'm going to put that plus sign by the and. The sum of the number and 9, they give us that. So this is going to work out to be 2 times, and I don't need to put a multiplication symbol there because the parenthesis will apply it, twice the difference of a number and 8 is equal to 3 times the sum of a number and 9. So if you can chunk the sentences out, you know, these take some time to do and get comfortable with, but with practice you'll get better. Okay, so these are just 3 examples of how we work these sentences up. Oh goodness, okay. So let me go ahead, let me explain working number 3. My apologies, I didn't see it went into there before. So it says twice the difference of, so twice the difference, so here's the difference. What am I taking the difference of? A number and 8. So the division, the subtraction symbol is there because of the difference. The number 8 is equal to 3 times the sum of, so the sum of 2 things. What's the sum? A number and 9. So this is how the expression gets written for number 3. My apologies for not showing that in the work there. I'll go down to the next question and see if we can help you out with number 4 now. So it says a 20-foot piece of string is cut into 2 pieces so that the longer piece is 5 feet longer than twice the shortest piece. Find the length of both pieces. Well, it's cut into how many pieces? 2 pieces. Okay, so we're just going to draw a string here. And what we're going to do is we know that it's equal to 20 feet. And we're going to make sure that one piece is going to be longer than the other, so this is going to be the longest piece. And we're going to talk about the shortest piece now. So let's go ahead and read this part, and let's see what the question states now. A 20-foot piece of string is cut into 2 pieces. Here's one piece, here's the other. It says the longest piece is 5 feet longer than twice the shorter piece. Now, you see how they mentioned this last part at the end, the shorter piece? Well, the shorter piece we're just going to call x. And that in the second part of the question, when we refer to this as just x, that's going to give us something to work with when we talk about how much bigger this piece of the string is than this piece of the string. And what does it say? It's 5 feet longer than twice the shorter piece. So first off, what's twice? 2 times. So twice, so it's 2 times longer, but it's not just 2 times longer, but it's also 5 feet. It's also 5 feet longer than twice x, so twice the shorter piece. So if the shorter piece is x, twice the shorter piece is going to be 2x. 5 feet longer, that will give us 2x plus 5. So if we have 2x plus 5 plus x equaling 20, then the equation we can get out of this is going to be 2x plus 5 plus x is equal to 20. Now this one, because people probably want to know what this is going to be, I'll go ahead and work this out. So 2x, well, let's do this here. So we have 2x plus x equals 20 minus 5. Or we're going to get 3x is equal to 15. And if we take 3x equals 15, and we divide both sides by 3, we're going to get x is equal to 5. Now, the reason I worked this out is because there's a little added dimension to this problem. If it wants to know the length of the shorter piece, I would call it x, and then here I would say x is equal to 5. Here we have the longer piece written algebraically as being a 2x plus 5. So at this point, it's not sufficient to say that the longer piece is going to be 2x plus 5 feet. We need to take the value of x, and we need to put it into this. So if I know the longer piece is equal to 2x plus 5, and I now know the value of x to be equal to 5, I need to put that in to here to get 2 times 5 being 10 plus 5 being equal to 15, and that's going to be in feet. So that's going to equal 15 feet. So when you're doing a question like this, it's not only important to be able to construct your expression, it's also important to, when you solve the equation, make sure that you're answering the question they're asking. And it says they want the length of both pieces. Just remember, when you take my midterm test, you're not going to have multiple choice questions that kind of give you clues as to what the answer can or should be. So just wanted to mention that. Here we go. It says the flag of a country contains an isosceles triangle. Recall that an isosceles triangle contains two angles with the same measure. If the measure of the third angle in the triangle is 35 degrees more than 3 times the measure of either of the other two angles, find the measure of each angle of the triangle. Okay, so we're going to go ahead and take a look at this. So they provide this flag. I mean, I could see where an isosceles triangle could be put in here, but it's not necessarily really helpful because the triangle is not apparent. I think the triangle they're talking about is the triangle that emerges there. Okay, so we know that one thing it mentions here is that the sum of the measures of angles of a triangle add to 180 degrees. So if we know that, then we're going to go ahead and create a space. So we have 3 angles that are going to add to 180 degrees, even if we don't know what the angles are yet. But it says the measure of the third angle of the triangle is 35 degrees more than 3 times the measure of either of the other two angles. Okay, so since I don't know what these other two angles are, for the sake of simplicity, I'm just going to call these x and x. So let's say, how do we get 35 more than 3 times? So when you see the word more than, that's usually like plus. That's going to be like 35 plus 3 times the measure, 3 times the measure of either angle. So 3 times whatever this angle is, that's going to be 3x. Now, word of caution, we're seeing more than, and because it's addition, you could put 35 plus 3x. But usually we would write this as like 3x plus 35, because in the case that we should happen to stumble upon division, or it means not division, subtraction, then we would have to write this as like 35 minus 5x. This is like 35 less than that. So just putting it out there. So now we have an expression. It asks us find the measure of each angle in the triangle. So I'm going to write those above here. So I'm going to have x plus I'm going to switch this around now. 3x plus 35 equals 180. I could write the equation now if I wanted to as x plus 3x equals 180 minus 35. That would give me 5x equals 145. And if I divide both sides by 5, oops, moving up here a little bit, 5x equals 145. If I divide both sides by 5, I'm going to get x is equal to, hold on, 145. I want to say x is equal to 29 degrees. So I have now an answer of 29. What I'm going to do now to find this angle is, I know this angle is x, so this is 29. I know this angle here is 29. Here, if I want the measure of this angle, I know this third angle is going to be equal to 35 plus 3x, or 3 times 29. So 3 times 29, that's going to give me 87. And then 87 plus 35, 97, 107, 117. That's going to give me 122. So the measure of that angle is going to be 122 degrees. So the 3 angles that are going to be included in that shape. Oh, guys, let me show this work over here. I'm sorry. So once again, I lose track of this sometimes, especially when I try to show the word problems very closely. I took the value of x being 29, and I put it into 35 plus 3 times x being 29, and I get this value of 122 here. So now they have 29 plus 122. You can check your work and see that those answers add up to 180 degrees. I'm going to go ahead now and let's see, we're going to go to question 6. Actually, no, I won't be able to do this one. Let's see. The left and right page numbers are open book, are 2 consecutive numbers whose sum is, I can't do it. But if you want to know about the sum of the pages in the book, the way this is done is the following way. You want to add the 2 pages in the book, whatever those numbers add up to be. The first page I would go ahead and write as x. The second one I'm going to write as x plus 1. And whatever the total is here, I'm sorry that this does not come out of my paper, you're going to put the total there, and that's going to give you your equation to solve. All right, let's take a look at number 7 now. 4 times the number subtracted from 9 is twice the number. All right, find the number. So obviously we're going to find that number. At least I'm going to give you the equation to find that number, but I won't bother to solve it here. Here is the instance where the word is going to count as that equal sign. So let's just take a look at what this says. Twice the number. Well, whatever the number is, 2 times the number. 2 times the number x. 4 times the number subtracted from 9. Okay, now be careful of this. Here's that phrase, subtracted from. So, subtracted from, this is a flip statement, as I've mentioned in previous problems. So you see the phrase subtracted from, so then we're going to establish what these things are going to be. So what's that? 4 times the number? 4, so 4 times a number subtracted from 9. But if it's 4x subtracted from 9, this is going to read 9 minus 4x. So you have 4 times the number, 4x subtracted from 9. I have to flip that around to make it 9 minus 4x. That's going to equal 2x. And that's going to be the equation we get for question 7. So when you see that phrase subtracted from, always remember that's going to be a flip statement. You're going to have to turn that around. Okay. Question 8. The sum of 3 consecutive integers is 189. What are the integers? Okay, so if you want to write 3 consecutive integers but you don't know what they are, it says the sum of 3 consecutive integers is 189. Well, first off, you're adding 3 things together. We know if you add them together, they add up to 189. Well, let's just pick some numbers. Let's say this were 10, 11, and 12. How much bigger, let's say this is just 10, 11, 12. How much bigger is 11 than 10? Just 1 bigger. How much bigger is 12 than 10? It's 2 bigger. So if I write this as n, I can write this next one as n plus 1. And the next digit would be not be n. It wouldn't be n plus 1. It would be n plus 2. So if you want the sum of 3 consecutive integers, first integer would be n, the second would be n plus 1, the third would be n plus 2. And if I kind of combine all this, well, let's see. I'm getting away from my technique here, but if you were to just combine all these together, that would give you 3n plus 3 is equal to 189. How all that will combine now. That's abandoning my technique a little bit, but I hope people are comfortable with what I'm doing here. If I subtract 3, that's going to give me 3n is equal to 186. If I divide by 3, I'm going to get n is equal to 62. So now I know what n is, but I don't know what all of the consecutive integers are. I do know that the first integer is n. I know that the second one is n plus 1. I know the third integer is n plus 2. Well, if this is n, this is going to be 62. N plus 1, or sorry, 60, yeah, is going to equal 62 plus 1, which is 63. And the third one's going to be 62 plus 2, which is equal to 64. And in fact, if you add all these together, 62 plus 63 plus 64 will in fact give you 189. Okay, let's take a look at question 9 now, making sure that everyone can read what's on there. Okay, very good. 2 angles are supplementary if their sum is 180. So what I'm going to do, I'm going to create the space because I know I'm going to be adding 2 things that are going to add to 180 degrees. And I'm going to try to figure out what is going in each of those spaces. It says the larger angle measures 30 degrees more than twice the measure of the smaller angle. Make that your smaller angle. Just whatever that second thing that's mentioned there, we talked about this in a previous problem. Make it x so we can compare it. What's twice the measure of the smaller angle? It's twice this. So this is going to be 2x. It's 30 degrees more than. More than, that's addition. So that's going to be plus 30. So here's the larger angle, here's the smaller angle. These are the 2 things that add to 180. And now we're going to go ahead and find the measure of both angles. So I'm going to write this now without the space. It's going to be 2x plus 30 plus x equals 180. I can write this now, I'm going to move this up a little bit here. I can write this as 2x plus x equals 180 minus 30, or 3x is equal to 150. Well, once I get to that point, if I divide both sides by 3, I'm going to get x is equal to 50. And what does 50 represent? That represents the measure of the smaller angle. So if that represents the measure of the smaller angle, then that means that 2 times 50 plus 30 is going to represent the measurement of the larger angle, and that's going to give us 130 degrees. And in fact, 130 plus 50 does work out to be 180 degrees. So there is all the work shown for that entire problem, just kind of in one picture if you'd like that. And that is calculating the work and showing the answer for question 9. And to just show the answer for that, the smaller angle is going to be 50 degrees, and the larger angle is going to be equal to 130. Okay, let's go ahead and take a look at question 10 now. It says 1/2 of a number is 3/4. So that's going to be the equal sign. 1/2 of a number. A number is x, 1/2 is equal to 3/4. That's 3/4. So the equation of this is 1/2 x is equal to 3/4. Now, you probably, if you know the techniques we learned about in the last section, you could probably solve that one without a lot of difficulty. Finally, question 11, this is going to be the last question we're going to cover in section 2.4. This is 80-foot piece of siding is cut into 3 pieces. So that the second piece is 4 times as long as the first piece, and the third piece is 5 times as long as the first piece. As x represents the length of the first piece, oh, they're really nice to give that to you, find the lengths of all 3 pieces. So let's go ahead and draw a picture of what these pieces look like, shall we? So I'm going to just put piece 1 here, piece 2 here, and then piece 3 here. What does it say? The second piece is 4 times as long as the first piece. So if this is x and this is 4 times this, 4 times, what's the length of the first piece? X. 4 times as long as the first piece. What's the first piece? X. 4 times x. And it says the third piece right here is 5 times as long as the first piece. 5 times as long as the first piece. 5x. So there's our algebraic labeling of what those 3 pieces are going to look like there. It says that vector represents the length of the first piece. Find the lengths of all 3 pieces. So again, if you'd like to try to solve this on your own, you can, but going from this point forward, I'm going to go ahead and find the length of all 3 pieces. If you pause it, great. If you didn't, here we go. This is going to be these 3 pieces adding together to make up 80 feet. So x, 4x, 5x, and not much moving around here needed because all the variables on one side and all the numbers are on the other. That's going to be 10x is equal to 80. And if I divide both sides by 10, x is going to equal 8. From that point, if I want the length of all 3 pieces, well, the first one's going to be easy because that's 8. Okay, I can take 4 here times 8. That's going to equal 32. And here I can take 5 times 8. That's going to equal 40. So when they want the length of the first, second, and third piece, make sure this is in feet. So the way you're going to have to express your answers in all of this is going to be 8 feet. The second piece is going to be 32 feet. And then the third piece is going to be 40 feet. And let's see if I can capture all the work here. Not quite, but yeah, no, actually, I got all the work there. And that concludes this activity for lesson 2.4.